Good day, class. Today we're going to go over the assignment 9 test review, and the biggest thing I want you to do is make sure you do a couple of things. When you do this review, I want to go ahead and make sure you try it first. So try each problem first, and then if you are stuck, then view the video with each problem. Now the reason why I am doing all this is that even after you go ahead and write it down and see what I did, one of the things that's very important for you to do afterwards is to go ahead and retry it again. And the reason being is because, first of all, in the learning process, you got to make sure you're able to remember what you did. You got to be able to understand it. And then you also have to be able to apply it. And that is where it's crucial, where you want to go ahead and do these steps right here with each problem that I'm doing, and then go ahead and do it until you feel that you could do it. When you could tell yourself, I've mastered these 3 steps with every problem in here, then you are ready. That means you've actually completed the most important part of the learning process in regards to these items right here. Now let's go ahead and get started with some of these questions, and we'll begin solving it. Now, the first question, let's read the directions. It says change each exponential expression to an equivalent expression involving a logarithm. So with this one, we have to do something called the log loop. And the log loop with these is something that's fairly simple. And really what it is that this space that you see here is going to be log looped right over here. And so you see that exponent becomes this log, becomes the new base of this. Log of x of 8 is equal to 5. Now, the log loop is something you got to get comfortable with. So when I log loop this one, I'll get x is equal to log, becomes the new base for the log, 3, and the exponent in itself is the one that becomes the equals. So you're going to have to get comfortable with that process when you do the log loop. Now, let's go ahead and do the log loop with the questions below, because it says change each logarithmic expression to an equivalent expression involving the exponent. So again, we're going to be applying the log loop, and this time we're going to be applying it backwards. So in this case, it'll be x is equal to 5 cubed. And in this one right here, we're going to do the log loop as well. 4 is equal to x raised to the power of 7. Now, if you notice, none of these questions involve anything about solving. So all you have to do is just change the expression. So that makes it nice. Now let's go ahead and do these. And with these right here, let me go ahead and also get my calculator up and running. So then we could go ahead and show you how to get the exact value, but also without using the calculator. Now, if anything, you may want to use the calculator just to verify you got the right answer. Because then you could tell to yourself, oh, no, I did something wrong, and if it's different, and you have to go back and redo it by hand. Now with these, the way this works is like this. You will still be using the log. Remember, this is going to be equal to a value that we don't know. So with this one, we're still going to log loop it to get it in an equivalent exponential form. So there it is, log loop. Now, what we're going to do afterwards is go ahead and find out what is 81 in the terms of 3 base. So 3 is equal to an unknown that if 3 gets multiplied by x a certain amount of times, it becomes that. So like in our case, all you really have to do is, let me clear this. Let me get back into the actual edit mode on this, and we'll go ahead and actually try this expression now. With this, let me go and quit out of this. Now with this one, you may want to try some numbers. If you're completely lost, just try some numbers. Try like 4. See what oh, there it is. X is equal to 4. So I tried it in the first try. For you, it may take a few other tries. You might have tried 3 cubed first, and then eventually you would have found out that 4 is the answer. So what does that mean? That means that in this case, with this one, the unknown is 4, which means that the final answer, x is equal to 4. And that's the answer for this one. Okay, fantastic. Now let's go ahead and do the same thing here. Let's make this equal to x. And again, we're also going to log loop it. And we'll end up with 1/16 is equal to 4x. Now, with this, if you notice 16 is at the bottom, so we're going to have to put in an equivalent form. So let me go ahead and show you what I'm talking about. 1/16 is equal to 1, 4. Now, when you move the exponent down to put in an equivalent form, you'll find out that the x becomes a negative. And then we're going to put everything in terms of 4. Now, we all should know that it should be 4 squared. 4 is negative x. So that means in this case, 2 is equal to negative x. I have to divide by negative 1, divide by negative 1. Find out the answer really then is x is equal to negative 2. And that's the answer for that one. Okay, let's go ahead and move on. Now let's go ahead and expand. It says expand the logarithm, write each expression as a sum or difference of logarithms. Now remember, the important thing you have to memorize about this one, if you've forgotten, is that when you expand a logarithm, multiplication, like with these right here, this is going to be all multiplication. I'm going to be adding logs. This one involves both. This one involves multiplication and also when you divide a log, this one right here, you're going to be doing minus, subtract in between logs. But let's go ahead and begin with 7 before we go to 8. Now with 7, when you do the expression or the simplification, log of 8, and then you do 5, and then you do plus log m squared, and plus is going into effect, oh, don't forget my base 8, log base 8 n squared. Now you're not done there, because it's also important that these exponents become coefficients in the front there. So that's what I'm going to do next. So with this one, my final answer is going to be log base 8, 5 plus 2 log 8 m plus 7 log 8n. And this becomes my final answer. Okay, good. Now let's go ahead and deal with this one over here. Now with this one here, these multiplications that you see here are going to show up as pluses. That line that I have already is going to show up as a minus, and we'll have a minus and a plus there. So let's go ahead and begin this one. Now this one's going to look like this. Log a cube plus, log base 2. Log base 2, b, plus log base 2, c. Now this is where the minus comes in. And it's a minus, and this becomes log base 2. Let's see, log base 2 d4 plus log base 2 f. So with this, we'll go ahead and continue simplifying this one. Now this one is going to remain as, how do we put it? We're going to go ahead and continue. So we're going to now begin in doing the process of moving the exponentials to the front of it. That's the thing we're going to do with this one. So this one, the exponential, will move to the front. That one will also. So let's go ahead and actually bring up, what the final answer would be. Now just accept and take one. All right, so let's go ahead and continue with it. Now this one, this is how this is going to look. This is going to end up being 3, and let me write a line here so make sure you don't get confused with the other side there. 3 log base 2 of a plus log base 2 of b plus log base 2 of c. And then this is going to be, now remember this minus is going to be distributed to both. So like in this case, this is going to become minus 4 log base 2d minus log base 2f. And that will be my final answer there. Okay, great. Now, let's go ahead and move on. Now, with everything that we're doing, remember, I'm expecting for you to pause and try them, and then, again, retry it again. You know, it's important you do that. Now, let's go ahead and move this one. And now with these right here, the first step when you're compressing the logarithm, and write the expression as a single logarithm, it becomes essential that we first start with moving the coefficients back into exponents. So there you have one there. So, and like this one, you have one here. But let's go ahead and start with number 9. And with number 9, oh, and then this one, the half. So this is what the new form of this should look. Log. Let's see, and let me extend here the page a little bit because I want to make sure that I have an even writing surface. But here, log of n to the 1/2 power minus log of p cubed. Now, this is something important. Y'all see the minus right here? You can factor out that minus. So what's going to happen is you're going to have log m minus log n to the 1/2 plus log p cubed. So when you go ahead and compress it, we'll get this as a result. Log of m. I'm gonna put divide sign, and the divide sign comes because of that. And actually, you know what I should do? What I want to do here, let me write it this way, and I'll change the colors. So log of m and divide sign. Go ahead and use this one, which is kind of like a. I want to go ahead and point that out, and then on the denominator part of this, it's going to be n to the 1/2 p cubed. So that's how you get that. Okay, and then this is your final answer. Now let's go ahead and move on to this one and do this one. Now with this one, we're going to have first we have to move that part of it. So let me go ahead and now do this. Log base 2 x squared plus 5x plus 4, and we also have minus log 2x plus 1 squared. Okay, now when we do the compression, we'll get log base 2 x squared plus 5x plus 4 all over x plus 1 squared. Now, we're not done because we're able to factor this. And so like on the top part, that becomes, if I do a times c, that's 4. Another factor of this one is going to be 1 and 4. So log base 2 will have x plus 4, x plus 1. At the bottom, as the denominator, we'll have, I'll expand the x squared, which is really x plus 1 and x plus 1. Now if you notice, those two end up canceling out, which means that my final answer is log of 2 is x plus 4 all over x plus 1. And that is the simplified form of my compression expression. Now let's go ahead and move on to the rest of this. Now this one, they want you to rewrite the expression. Question 11 says rewrite the expression following using the change of base formula. Then evaluate each expression using a calculator, and you round your answer to 3 decimal places. So with this one, when you do a change of base, okay, let's say you have log of AB, then the change of base is really just a log of 13 over, or let me write it in general terms. It's going to be the log of B divided by the log of A. So that's what we're going to do with each one of these. And let me go ahead and begin with that. So I'm going to do log of 13 divided by log of 7. That's how you do the change of base. So when you bring out your calculator, let's go ahead and put that in. Okay, so you come to a log about formula. 13 divided by log of 7 and you get 1.38 as an answer. Now, if you ever want to, also, there is a way you could put a base into log. You just have to hit the alpha, enter. You see I got log a base on as option 5. Go there, and you always could enter in case if you thought you did it wrong. So if you put a 7 there, put a 13 there, should have this, the same answer should come up. So if you see, the log base formula is valid. So let's go ahead and write that answer on here. Let's put our calculator back up and let's write that number out. 1.318 is the answer. So the answer of this is 1.318. Okay, let's do the same thing with the next one. The next one, same concept. Log of 42 divided by log of 1 divided by 3. Now I put in parentheses because that's how you want to put in your calculator. I think it kind of has you do it automatically. But let's go ahead. Oh, that one's writing. So let's go back, clear this, and let's actually get into, I'm putting that in there. So let's clear. Let me write in the log of 42 divided by, ooh, see that? Gotta make sure we close up that parentheses and now put log of 1 divided by 3. Like this, and we end up getting negative 3.40 as an answer. So let's go ahead and write that down. So this is really equal to negative 3.402. Remember, every time you round to 3 decimal places, go ahead and please round to 3 decimal places. Now, again, if you want to double verify, hit alpha window, go to the log base for component of it, and just type it 1 divided by 3, 42, and the same answer comes up. So we're good. All right. Now let's go ahead and do this part of it. It says solve each equation. And with these, it's important that you know how to solve logarithms. We had that at one assignment, but you have to realize that if you ever have 2 logarithms that have the same base, you could go ahead and just cancel them out. And just whatever's left over, equal them. So like in this case, I'll have this 2x minus 5 is equal to 3x plus 4. So if I start solving for this, I'm going to go ahead and get numbers on one side, exponents on the other. Negative x is equal to 9, which means that divided by negative 1, divided by negative 1, x is equal to negative 9. So there's your answer for that one. Now, question number 14 for solving this one is going to be started with the application of moving first the exponent to the front there. Okay. So once we do that, we'll end up with this. Log of 3, 2 to the 5th is equal to the log of base 3, x plus 4. Now with this one, same thing happens. The logs cancel out. So we got 2 to the 5th. Let's see what that is in terms of numbers. 2 to the 5th is, oh, put 22. I need 2 to the 5th. Okay, now 2 to the 5th means it's 32. So like in this case, we'll have this side being 32. And that's going to be equal to x plus 4. So subtract 4, subtract 4. You end up having that 28 is equal to x. And there's your answer for this one. Okay, let's go ahead and move on to the next question. Okay, we're going to have this one here. Now this one is probably important to go ahead and make this into a logarithmic function because so when we do the log loop on this, we'll get x is equal to log base 4, 15. So from there, you could go ahead and use your calculator by either doing the change of base formula to go ahead and find out what x is. So with this one, going to go ahead and do that. Try to have that up. Okay, so look, now I'm going to go to alpha window because I'm going to use the one with the change of base formula. Enter. I'm going to put 4, 15, and there it is, 1.9534. So with this one, the answer is going to be x is going to be equal to 1.953. That's what the answer is going to be on this one. Okay, now let's go ahead and move on to the very last one. Now with this very last one, if you find this on the test, you may want to save it until the end because it's quite involved with it. Let me show you the answer before I see the process, and then from there decide. You go ahead and start learning the mastery of this one. So let's go ahead and begin. Now with this one, the essential thing we're going to have to do is try to get these exponents, the variables that are exponents into actual manipulatable forms. So the way we do that is that we use natural logs. What do I mean? I'm going to apply a natural log on this side and also a natural log on this side. Now you might be wondering, Mr. Sandoval, why are you applying a natural log? It's because once I'm able to apply a natural log, I'm actually able to move the exponent as a coefficient of the natural log, and that's very important in solving this problem. So let me go back and show you that. 2x plus 1, natural log of 5 is equal to 5x natural log of 4. Now, I'm going to go ahead and distribute this one because it's important that kind of separated. So I end up with this. 2x natural log of 5 plus 1 times the natural log of 5, which is really just the natural log of 5. And this is going to be equal to 5x natural log of 4. Now with this one, go ahead and extend the page. I'm going to go ahead now and move this whole expression on this side. So I end up with this. 2x natural log of 5 minus 5x natural log of 4. Now I'll do something here because I just want to save not to be writing so much. I'm going to subtract this natural log of 5 and subtract it over here. Well, here, let me do this. I'll put it over here on the side because remember, currently right now the way we have it is that this has canceled. Okay, and this has canceled. And what's left over is really just this negative natural log of 5 over here. So the reason why I want to do that is when I'm writing this equation, something happened to my color blue. So I'm going to go back. I'm going to use black. It's going to be like this. Now, from here, the reason why I did all this manipulation, I noticed a mistake right here. This is not really n, this is x. So the reason why I did all this manipulation here is because I wanted to factor out this x. And that's what I'm going to do precisely. I'm going to factor out this x because now by factoring I'm able to isolate that x. And the isolation is going to occur in the next step. Natural log of 4 is equal to negative natural log of 5. And here comes part of the grand finale, what I did. I'm going to go ahead and divide it by this expression. And division of this is going to make sense that that's going to divide into 1. So natural log of 5 minus 5 natural log of 4, which means in this case I could go ahead and do this to that, and I'm left with this expression. X is equal to this right here. Now this could be solved in your calculator. And the way that's going to go about is like this. Let's go ahead and let me clear this. Let's get it clear. Okay. I'm going to put the negative natural log of 5 there, divided by. I'm going to put it all in parentheses because I want to make sure that it's all done correctly. 2 times the natural log of 5 minus 5 times the natural log of 4, and we close it up. And the answer was 0.433, which means that that's the amount I'm going to write here. 0.434. I'm going to stick to the 3 decimal places just because in the top directions is what it was asking for, so I'll go ahead and stick with that. But here you go. Here's the answer. And that's how you solve that one. Okay, great. Let's go ahead and move on and do the next one. Now this one is still with the other one about solving. So with this one, the process on this is going to involve us to go ahead and first combine these natural logs. So with this one, let's go ahead and combine them. I'll get log, compress them, better put, compression of the natural logs. So I'll be able, since they have the same base, I'll have plus x all over x squared minus 1 equal to 3. Now from here, it's important that you're able to log loop this. So what I'm going to do is I'm going to go ahead and log loop. And I'll end up with, I'll start over here because I want to make sure I have enough space. X squared plus x is over to x cubed minus 1 equal to 2 cubed. Now this 2 cubed is really 8. Now from here, I'm going to have to start solving. So I'm going to go, first thing I want to do is get this x squared out of the denominator spots. I'm going to multiply this by x squared. And multiply this side by x squared minus 1 as well. And these go. And I'm left with this. X squared plus x is equal. And I'm going to distribute this right here. So I'll end up with 8x squared minus 8. Now, I like to deal with positive numbers, so I'm going to subtract the x squared here. Because remember, we had to set all this equal to 0 to solve. And I'm going to subtract the x too. So let's subtract x there. So right now, those are gone. I'm able to say 0 is equal to, that becomes 7x squared. And I'm going to put it in the correct order. Now from here, we're able to factor this. And what you got to try, before you use quadratic, you should use the a times c method. And we have 7 times 8, 56. There's 2 factors that will add up to, multiply to 56, but it could add up to -1, which is going to be 8 and 7. So we'll use 8 and 7, and it's going to be -8 and 7 in this case. So let's go ahead and use that. With the a times c method, you do x minus 8 and x plus 7, and then you also have to divide by a. So we're going to divide that by 7 and divide by 7. So with this, I have now 2 expressions in where, let me use this part over here, because I want to go ahead and show you. We break that up to find out what each one individually is. X minus 8 over 7 equal to 0, and x plus 1 is equal to 0. The 1 came from this right here, 7 divided by 7. So from here, I find out that x is equal to 8 divided by 7, and x is equal to -1. So there's my 2 solutions for this logarithmic. And if you're ever in doubt, you could always re-plug them in and see if it equals that amount. And if it does, that means you have a right answer. Okay, great. Now let's go ahead and start using the, let's go move on to the next set of problems, which is using the proper interest formulas, find the amount resulting from each investment. Now with this one, let me preface this a little bit and also say that there's 2 interest formulas, 2 main interest formulas we're going to be dealing with. A is equal to P 1 plus R over N times T. Hold on a second.
Scott, plug in your student F5, please. Scott, plug into F35, please.
Now, let's continue with this. It's either going to be that one Or you're going to have other ones like this one. You see how this one says compounded continuously? This is where it's essential that you use the formula PERT, which is the exponential e to make compounded continuously. Now with this one, let's go ahead and now with each one of these, I do want you to use your calculator to verify, but you need at least a setup of this to be able to also, um, I guess better put, know how to use the equation. Now this one says $700 invested at 13% compounded weekly. So after a period of 4.5 years, so you want to know what the future value of the formula is going to be. So with this one, this is P because it's the amount that's now. That's what P stands for. So this is what this is going to look like. A is equal to 700. 1 plus, now 13%, you got to convert it to a decimal here. So it's actually converting it wrong there. So let's fix that. Remember, you move the decimal over twice. And it's compounded weekly, so that n is 52. And so you'll have 52 times 4.5, which is 4.5 years. So if you notice, we have all that there. And if you want to, for me to write down what P is, 700, rate 0.13, N was 52, T was 4.5, and you have that there. And that's how the equation got formed. So from this, you should be able to put everything in the calculator and go ahead and just solve it. Now, I know some of y'all got familiarized with the apps feature of this, so I will too. I could go ahead and actually just use that as well. And it'll come out being the same thing. So let's go ahead and apply both and verify it through both ways, depending which one you feel more comfortable with. 700, 1 plus 0.13 divided by 52. Now, that's an exponent, so you got to make sure you put the caret on there. 52 times 4.5. Oh, hold on. It didn't register my 52 correctly. Times 4.5. And the answer should be 700. Something did not. Oh, I know what happened. Okay. Important. If you notice on my equation, I did not close up the parentheses here. Oh, went a little too far. Okay, right here. I opened a parenthesis, but I should have put in a double parenthesis, so I'm going to insert that in now. And now I should have the right answer. There it is. That is the correct answer there. Now this answer should also be able to be generated from the apps menu on this. If you hit apps, and you go enter into the TVM solver, same thing should be able to apply. 4.5, interest rate is 13. Now PV with this, remember you got to, in this one you got to make sure you use negative if you're going to use this menu. And compounding periods was 52. So for this one, the future value, alpha, remember hitting alpha enter will produce the same value, which means that that's right. Now, the compounded to continuous formula, you can use the calculator to verify, but you can use that menu I just showed you because you have to use PERT. So with PERT on this one, let's go ahead and define which each one is. Well, let me write down what it should look like first. This one's going to look like this. A is equal to 500 e to the 0.05 times 3. And in this case, P was 500. The rate was 0.05. And time was 3. And that's what all you see there. So with this one, let me go ahead and get out of this mode. And type all that in. 500. Now remember the E is above the natural log, so you have to hit second natural log and type in 0.05 times 3, and there's your amount. It means in this case my value is 580. So A is equal to $580 with 92 cents. Okay, good. Now let's go ahead and do these to get $450 after 5 years at 3.2 compounded monthly. Now with this one, it's a little different because you want to get 450. So that means that we don't know what the p-value is on this. So um, let's go ahead and show you for this one. That means that we know what A is. So this is what the formula is going to look like. We're going to use that other formula because you see how it says compounded monthly? We're going to use this formula here. 450 is equal to a p that we don't know, but we know it's 1 plus the rate, 0.032. Compounded monthly means 12. And in this case, it's going to be 12 times 5. Okay. Now, with this one, these are easy because all you have to do is just divide by the whole amount. Like divide by 1 plus 0.032 divided by 12. 12 times 5. And do that here. 1 plus 0.032 over 12. 12 times 5. And this will cancel. And you know what P is. And then we'll also use this one. You can use the other one to verify the applications menu on there. So with this one, let's go ahead and just see what your answers you come up with. So this one, let's go ahead and type in 450 divided by, you know, with this one, I'm going to use double parentheses because there should be 2 parentheses here. So I'm going to use double parentheses just to make sure that everything's encompassed. 0.032 divided by 12. Let's see, erase that. 12 times 5. Let me close that up. And make sure I didn't make the same mistake I did before. No, I think I'm fine in this one. So I have that. Yeah, I'm good. Okay, so I have, you notice from the big and small parentheses, that means I've opened and closed everything correctly. So the answer should be 383.54, 383.55 if you round up. So let me go ahead and write that in. 383.55. Now let's double verify that using the apps menu and the calculator. So we go ahead and go to the apps menu. Enter in there. Now this one is going to be the, move this a second. Interest rate was, well actually the term in this one was 3 years, right? Or 5. No, 5. This one's 5. Interest rate on this was 3.2. The PV on this, we don't know. So we're going to put that as 0. The future value that we want is 450. And the compounding periods on this one is, let's see, 12, because it's monthly. So we go back up to where it says PMT, hit alpha, enter, and, oh, sorry, not PMT, PV. So let's go ahead and put that back to 0. PV, alpha, enter, and there you go. Negative 383.54. Remember, it's going to give it to you as a negative number because remember, anytime you're investing, it's money out of your pocket. So 383.55. So verify. So it's the same thing. Now let's go ahead and talk about question 21. Question 21 means you want to get $1,000 after 3.5 years. Semi-annual. You're gonna use the same idea that you have here. The only difference is that your compounding period is going to be different. So let me go ahead and just take you through the process on this one. You want to get $1,000. You don't know what P is. We do know that the rate is 0.045. Compounding semi-annual means 2. That's where that came from. And we have 2 times 3. Again, you just divide by this amount. 1 plus 0.045 divided by 2. 2 times 3. 1 plus 0.045 over 2. 2 times 3. And then from there you can use your calculator to solve in either method I've shown you before. So I won't go through that just because I'm running a little short on time and I want to make sure I'm able to get through all the problems. Okay, now this one right here says graph each of the following functions using transformation of the basics function And this specify at least three order pairs for the function, determine domain and range in a horizontal asymptote. So the first thing they want us to use is the basic function of this one. So the basic function of some of these is going to be the most reduced form of this. So the most reduced form of this one, like in this case, it's going to be f of x is equal to 4x. And we're going to go ahead and actually use that to draw the most basic form. Now with this one, once you have the most basic form of this one, remember you got 3 points that you're going to have. You're going to have 0, 1 with an exponential. So you'll have the point 0, 1. You'll also have the point, in this case, being it's 1a, and also negative 1, 1 over a. Now a in this case is 4, which means on these, I'll have a point there and a point here. So for this one, it means I have two other points I could fill in. I could fill in 1, 4, and also negative 1, 1 fourth. So right there. Now, let's go ahead and actually now talk about the transformations. You have this one involves a k value, which is this one. And this one also involves an h value, which is this one. Now, k value on this one. K is making this one shift down. Everything shifts down by 2. And the h value, which is the horizontal, is making everything move to the right by 3. So shift down by 2, right by 3. So this is 2. This is 3. So that means that in this case, my vertical asymptote typically that I have y equals 0 will be shifted down by 2. Because remember, with exponentials, you always have. So like in this case, I got to shift that vertical asymptote down. Now, each of these points are going to be moved down 2 and over 3. So I'm going to go count down 2, over and to the right 3. 2 to 3 here. Actually, you know what? Let me use a different color. Okay, so and then same thing here. Down 2, over 3. So and down 2, over 3. So with this one, we will have.
Students, those who have received federal aid and tax.
Okay, let's go ahead and continue with this. So with this one, we're going to go ahead and actually have transformation looks like this. Remember, here's my new points. There, there, and there. So this new exponent will look like this. If you wanted to draw the old one, let's see if they want us to graph this one. Graph, using each of the following functions using. Okay, so you don't need to graph the basic one, but it is important that you graph the main one. Now let's go ahead and talk about domain and range. Now the domain on this one is going to be all real numbers, because if you notice the x values, domain is everywhere on this line. And let me draw my little arrow. We'll continue that way forever. So for this one, domain, actually, let me change the notation. I want to put equals. Domain, so I'm going to put a is all real numbers, because it goes in all real numbers. Now the range will not. Range, there's nothing over here. So range is actually everything greater than, it's actually all real numbers of x, such that x is greater than, I'm sorry, not x, y's. We're talking about y's here. Go ahead and get let me get my right notation down. Y is all real numbers such that y is greater than, or well, actually not equal to, just greater than negative 2 in our case. So let me make sure I erase this equal sign and say it's everything greater than negative 2. And vertical, you want to know if there's any determine domain range and horizontal or vertical. Okay, there's a horizontal asymptote at y is equal to negative 2. So we'll have that there. Okay, so we're going to do that for each one of these. So let's go ahead and move on to 23, and we'll encompass 23 and do the same thing. Now with this one, it's going to involve the basic function of this one. It's just going to be the f of x is equal to 1/3 x. So with this one, we're going to again have the point 0, 1, and we're going to determine 1a and -1, 1 over a. And knowing that a is equal to 1/3 means that this is 1/3 and this is 1/3, which really means that this one right here, because remember the conjugate being multiplied is really 3. You might be saying how much down about 1 divided by 1/3 is really 1 times 3 over 1, which is 3. And that's how we get that number there. So here's my 3 points. So let's go ahead and plot those original ones from the original function, 0, 1, 1, 1/3, and -1, 3. Okay. Now, this one actually has, let's say it's called, this one has a b value, which is a -3. So there's no h, there's no k present. Now there's something that does occur because if our b value is equal to -3, remember b controls stretching or compressing. Like in this case, this one's going to be stretched, in this case vertically by 3. And it's also going to be, stretching by 3, and it's going to also be reflected over the x-axis because it's negative. So those two things are going to occur with this one. So because of that, there'll be actually quite a bit of transformations. And actually, you know, if you want to get an idea of how that's going to look like, let me go ahead and kind of show you. You can always pull out your calculator and kind of get an idea of what that looks like. Remember, you're still required to do all this right here as far as finding the basic functions, but at least you can see if you have the right idea by using your calculator. So let me go back to this and over a second quit. Y equals, this time we're going to have -3 parentheses 1 divided by 3 and parentheses raised to the power of x. And let's see how that graph is going to look like. And there you go. So you're going to have something like that. Now, when you have something that's being stretched by 3, which means that each of these points are going to be stretched by 3. I imagine that at -1, I'm going to have -9. And I know some of you are probably thinking about it is. -1, -9. The reason being is this. Once we have, well, remember, this one, there was no shifting at all as far as up and down. So we'll still have, this one will remain, still have a horizontal asymptote at y equals 0. But two things are going to happen. This is going to be reflected. And it's going to be reflected by a power of 3 stretched, which means that this one being point -1, 3, remember it's stretching vertically. B stretches vertically. Because of that, means that this one is going to be multiplied by 3, first of all, and it's going to be negative, so it's going to move everything down. So like in this case, it's going to reflect everything. So this one is actually, the point is somewhere way down over here, -9. This one should be 1 times -3, means that this one really should be -3 here. It's being reflected instead of being there, got also. Typically, normally the points would be here. Let me show you. There, but I'm multiplying by a factor of 3. And because of that, it's pushing everything down by 3. So I have now, let me erase those points so not to confuse you. 1, 3, and then this one will also be multiplied by 3. So typically being 1/3 means that it becomes, in this case multiplied by 3 is going to become 1. And so that means I'll have a point here. Now you always could verify in your calculator, and it shows up exactly the way I was thinking about it. -1, -9, -0, -3, and 1, -1. So you'll have finally something that looks like this. Now stating domain and range on this one means that you have on this one, the domain is on this is going to be, well, let's see, this is coming down this way. It's going down that way. That, it may seem a little unusual, but this one is actually all real numbers because that line will always continue going that way and that one going that way. Now the range on this one's going to be different. This is going to be y such that y is everything less than 0. Because if you notice, there's nothing up here. There's no range there. And this one has a horizontal asymptote at y equals 0 because there was no change in there. With exponentials, you always have that unless it's been transformed. Okay, good. Let's go ahead and move on to the rest of this. And let's go ahead and practice one of the logarithmics. I'll practice one of the logarithmics because look, for me, I'm going to have to go ahead and try to get to the back side of this before I run out of time. So let's go ahead and actually talk about number 25. Now, number 25, when you look at what's been transformed on this one, there's really only the basic function on this one would have been this. So if you're going to graph the basic function on this, basic function of this one will be f of x is equal to log base 3x. And with this one, and with logarithmics, you always have 3 basic points. You always have the point 1, 0. You have the point b1, and you have the point 1 over b, -1. So let's go ahead and find out what, in this case, my b is this value right here, which means b is equal to 3, which means this is 3, and this is 3, which means that if I go ahead and graph this, I will have 1, 0, and the other point being 3, 1, and the other point being 1/3, -1. It's right there. So those have been my 3 vantage points. You also have a horizontal asymptote at x equal to 0 with the basic function. But remember this one, I think it's going to shift, but the shifting on this one, I believe, is just the k value. The only thing when I see present on this one is just the k value. So since we have k means it's going to move everything up by 4. It's going to shift everything by 4. 4. Shift up 4. So with this one, I will still have a horizontal asymptote at x equals 0. Well, what's going to happen to each of my points? They're going to move up by 4. So 1, 2, 3, 4. Move that one. Move this one up by 4. So okay, right there. And this one up by 4 as well, which is there. So that means that I'll really have a function that looks like that. And coming out that way. Now, I'm going to define domain and range. Now, the domain on this one is going to be x such that, remember, there's nothing that exists over here. So it's going to be everything greater than 0. Range, though, on the other hand, is going to be all real numbers. Because you got everything. So you could talk about negative infinity to positive infinity. There's different ways to write the script of this. And we have a vertical asymptote at x equal to 0. Okay. Now, if anything, let me lightly touch base on number 24 before I move on. 24, you're going to have 2 things with this one. Because this one has an a value, and it also has an h value. Now, what's going to happen? This a value is going to stretch. Remember, a is equal to 2, so everything's going to be stretched by 2 vertically. There's no reflection because there's no negative there. But h, is equal to 3. So that means that in this case, everything's moved to the left. By 3. So that means that this one is going to, the horizontal asymptote is going to be moved by 3. Because, instead of x equal to 0, this one will be 3. And then everything else will also be stretched by 2. So that means typically the points you have are also going to be multiplied by 2 as far as the y. Okay, good. Now let's go ahead and actually get down to the very back of this. And the very back of this, it has to do with Shady. So let me go ahead and get some notes out to show you some Shady. Okay, now with Shady, you want to use a step process. You're going to have the ability to use this in your notes. So the first thing you want to do with step 1 is simplify. So if you want with the test, you're more than welcome to go ahead and take the test and write down. So this is, oh no, you know what, I think this is the right one? No, this is not it. You're able to use the test and also write down the steps for this one. So like with this one, you could say step 1. It's going to be simplification on this one. Now this one means that we could factor the bottom part. We're going to see if we could try to factor. Now I'm going to go ahead and use 12 and think about what two numbers could add up to 1, and I could automatically think about 4 and 3. So for this one, I'll have x plus 1, or not x plus 1. I'll have x minus 1. So I have x minus 1 is equal to x. In this case, since I want this to be positive, this is going to be negative then 3. So I'll have plus 4 and x minus 3. Now, if you notice this, I've simplified it. So I've done step 1. Now, step 2 has to do with the identification. If you're looking at your paper, is if there's any holes. And in this case, here you go. Oh, yeah, here you go. And in this case, finding this content, anything that, so like step 2, there's no holes when you're looking at this paper. So when I go back to this, you just got to write down no holes. So you've already done step 2. So there's another point. Okay, now step 3, go back to your notes. And this one says look for a y-intercept. So that means you set x equal to 0. So for this one, go back here and set x equal to 0. Now that's my equation there, which means I'm going to do this. Since I'm going to set x equal to 0, I'm going to have 0, negative 1. And then in this case, you can use the top equation if you want. Sometimes it's easier. 0 squared plus 0 minus 12. This comes out being negative 1 over negative 12. You can use either one, and I'll give you the same thing, but you'll have 1 over 12, which means that you have 0, 1 over 12. When we set equal to 0, this is what that means. This, in ordinate form, you're setting the x equal to 0 because you want to find out what the y point is. Now, step 4 has to do with, if you go back to your notes, you look at your notes, it's going to say look for the x-intercepts, and this is done by setting the px equal to 0. Now, with this one, means that you're going to go ahead and take the p of x in this one. So let's go ahead and actually go back to this. Remember, the p of x is this value up here. P of x is the top one. Q of x is the denominator. So our p of x is going to be x minus 1. So for p of x is equal to x minus 1, which is just the numerator, or this is the numerator. And I'm going to set that equal to 0. So 0 is equal to x minus 1. If you had two terms on top, you would set the 2 equal to 0, and we'll find out that x is really equal to 1, which means that you have a x-intercept at 1, 0. That's what it means by setting px equal to 0. Px is equal to 0 in this case, and that's how you find the x-intercept. Now let's go ahead and talk about the next one. Next one involves look for vertical asymptotes. And remember, you do this by setting qx equal to 0. And vertical asymptotes, just like when you're looking at the domain. I'm going to look at my qx, which is these values right here. And thus q of x is what I'm going to be looking for. So like with this one, I'll put 4 here. I'm kind of running out of time here. x is equal to -4, and x is equal to +3. So here's my two vertical asymptotes. Now step 5 involves the horizontal. Now that's going to become important to look at your actual notes and see. Oh, I'm writing on there. Hold on. Let me go ahead and just pause this. And see this part right here. We have a horizontal